Welcome back, everyone, to our discussion of tangent lines. So, quick review, make sure we're on the same page. Okay. If we have this function f of x, whose graph looks like this, no equation for it, but its graph looks like that, and we have this tangent line drawn into the graph, let's see if we can fill in these blanks. So, first one has nothing to do with anything we've done in Chapter 3. It goes all the way back to section 1.4. Namely, the first one comes from, this point 2,4 is on the graph of f of x. And so that means the input 2 goes with the output 4. So you could write f of 2 equals 4. Okay. Note, you definitely could not write f of 5 equals 5, even though this point 5,5 is there. Why? Because this point 5,5 is on the graph not of f, but on the graph of the tangent line. Okay, so this dot is on the tangent line, not on that. In fact, if you believe this, actually you'd probably believe that f of 5 is actually considerably bigger than 5 because it looks like this graph's going to be up here somewhere, not down here by the time that f ends up over there. Okay, so this is the only way I can fill in this first line. Now f prime, remember the derivative is telling me the slope of the tangent line. And so I'm going to take the slope of the tangent line. Well, this is the tangent line at 2. So I'm going to want to fill in the slope of the tangent line at 2. Okay. And now this line is the tangent line, so I can calculate its slope as 5 minus 4 divided by 5 minus 2, which is 1/3. Okay. And that is the slope of this line. And so that is the slope of the tangent line at 2. So I filled in here everything I could deduce from this graph. So, similar game. I've got a graph here of my function g. I've got a tangent line drawn in. I've got 2 points labeled on it. Let's start with g of blank equals blank. I think there are actually 2 answers that I could give here. Namely, I could say g of minus 1 is 2. But what else could I say? I could also say g of 4 equals 4. Because this point 4, 4, the second point, it also happens to be on the graph of g of x. Now, you might think, oh, so I'm going to also be able to give 2 answers here for g prime. But I'm not, and I want to emphasize why. This line is the tangent line to the graph here at this point, minus 1, 2. This is not the tangent line of the graph at 4, 4. If I were to draw in the tangent line of the graph at 4, 4, it would look something like this. It would be considerably steeper, right? It's not the tangent line just because it passes through the point. In order to be the tangent line, it both has to pass through the point, but also be going in the same direction. It has to have the same slope as the graph. And thus, I can't say anything about the derivative of g at this point 4, 4, because I don't know information about this tangent line. But I can say information about the derivative of g over here at this point minus 1, 2. So I can fill in what g prime of minus 1 is, and it's supposed to be the slope of this line, okay, which is going to be 4 minus 2 divided by 4 minus minus 1, which is going to be 2/5. Be sure you understand from this graph why it is that the derivative at minus 1 is 2/5, but the derivative at 4 is not 2/5. In fact, if you look at my picture, what you can convince yourself is, in fact, actually, if I did take the derivative at 4, it would in fact have to be much larger than 2/5, because the tangent line here is much steeper than this line here, which is the line that has slope 2/5. So again, the slope of this line is the same as the slope of the graph at this point, but it is very different from the slope of the graph at this point. Okay, so next I wanted to just do a couple practice questions of finding the equation of the tangent line to a graph with some of the more complicated sorts of functions that we put over here. So I want the equation of the tangent line to this function at this point. Okay. I need a point and I need a slope. Well, I've got the point, so what I need is the slope. And so the key fact from this whole section is that the slope of that tangent line is going to be f prime of 6. Again, at the input. So how are we going to figure this out? Well, we're going to find our 2 points. So we've got 6, 2. And then we're going to bump that point just a smidge to the right, to 6 plus h. We'll figure out what f of 6 plus h is. F of 6 plus h is 6 plus h divided by 6 plus h minus 3, which is 6 plus h divided by 3 plus h. Fill that in here. And then we're going to fill in the average rate of change between these 2 points. Okay, so here's our average rate of change. Again, change in output over change in input. We need to put this all over a common denominator. And I'm going to write the h out front as a 1 over h. And my common denominator here is going to be just 3 plus h, because again, this 2 is really over a denominator of 1. So this will be 6 plus h minus 2 times 3 plus h. And that is going to be 6 plus h minus 6 minus 2h divided by, and now h times 3 plus h in the denominator. This 6 and this 6 are going to cancel, and then I'm going to have an h minus 2h, which is going to leave me a minus h, like that. But now that h cancels with that h, and I'm going to be left with minus 1 over 3 plus h. Having done that, we can now fill in what our f prime of 6 is going to be, namely f prime of 6 is going to be the limit, as h goes to 0, of minus 1 over 3 plus h, which is minus 1/3. And so that is our slope. Now, we were asked for the equation of the tangent line. We have the slope, we have a point. Let's finish the question. So our tangent line is going to look like y equals minus 1/3 x plus b. And it's going to pass through 6, 2. When I plug that in, that's going to give me 2 is equal to minus 1/3 times 6 plus b, okay, which is going to give me 2 is minus 2 plus b. So that is going to give me that b is 4. And thus, our final answer here to our question about this tangent line is that the equation of the tangent line is y equals minus 1/3 x plus 4. Again, if we want to check our answer, we can graph our original function, x over x minus 3, and our purported tangent line, y equals minus 1/3 x plus 4. And if you pull that up in Desmos, it looks like this. And so you can see here our tangent line at the point 6, 2, and you can verify in the graph that it's really at 6, 2, and that it appears to have the same slope as the graph at that point. Just what we wanted. Let's do one more of these just to make sure that we are content with this. So here we've got to find the equation of the tangent line to the square root of 2x at 8, comma, and I didn't actually fill in the second point here. And I wanted to make a small point about that, is that in the previous question, I gave you 6 and then 2. Okay. This 2 was a freebie. I did not have to give it to you. How could you have gotten it otherwise? Well, this 6 is the other half of an input-output pair for the function f of x equals x over x minus 3. And so I could have gotten it just by computing f of 6 is 6 divided by 6 minus 3, which is 2. And that would have given me that 2. Okay. So some of these times when I do these questions, I'll give you the y-coordinate. Sometimes I won't. But if I don't give you the y-coordinate, it's fine. You can still figure it out. So in this instance, I can figure that out by calculating f of 8, which is the square root of 2 times 8, which is the square root of 16, which is 4. So that's one of our points. Then we want to go ahead and bump this point to the right, as we've been doing. So we've got our 8, 4, and our 8 plus h, comma, square root of 2 times 8 plus h. And I want to find the average rate of change between these 2 points. And that's going to be the first step towards finding the slope of our tangent line, which I'll remind you is going to work out to be k prime of 8. Okay, so I need to find k prime of 8. I do that by writing down these 2 points, the original point, then the point bumped to the right a smidge. Then I find the average rate of change between these 2 points. And then I find the limit as h goes to 0 of that, and that's my k prime of 8. Okay, so what's our average rate of change here? Our average rate of change here is the square root of 16 plus 2h minus 4 divided by h. And in order to make this work out, I have to multiply this by the conjugate. So I multiply square root of 16 plus 2h minus 4 by the square root of 16 plus 2h plus 4. And then I need to do the same thing in the denominator, because again, remember, the whole point of this is that this is a really, really, really complicated way to write 1. And so what I did here was multiply by 1 in a very fancy way. When I do this, what am I going to get in the numerator? Well, I'm going to get 16 plus 2h, and then minus 16. And this is going to be divided by h times the square root of 16 plus 2h plus 4. The 16s are going to cancel. And after the 16s cancel, I realize that I can now cancel these h's. And so that works out to be my average rate of change. So now what do I want? I now want the derivative, which remember is going to be my slope, k prime of 8. And that's going to be the limit as h goes to 0 of this thing I just wrote down. And so this is in fact 1/4. So the slope of our line is 1/4, and our line passes through 8,4. Okay, so our tangent line looks like y equals 1/4 x plus b. Passes through 8,4, so I can go ahead and plug in 8,4. Which will look like 4 is equal to 1/4 times 8 plus b. So that says 4 is 2 plus b. So that says b is 2. Okay. And so the equation of our tangent line is y equals 1/4 x plus 2. Okay, I know you've been conditioned to expect a graph, so here's a graph where we can check that indeed the line we just found really appears to be tangent to the graph at this point. All right, I'm going to do one more video about this section, where I'm going to talk about reading this information off of graphs a little bit more. But that's all for now. I'll see you all next time.